And in this small video tutorial, I want to talk about the importance of build testing streams. What I mean with that is that I believe one of the more complicated concepts in Angular is that of observable streams and the many ways in which you can use them. And what I found is that it can be quite finicky, like small decisions can have different impacts depending on different situations, and therefore sort of going about it in a sort of a build testing manner where you utilize the testing capabilities in combination with building it out. So that's what I want to show today by creating a little demo project. So what we will do is we will actually take this string that we have right here and we will turn it into one of those sort of animated spell things where you sort of see it get spelled onto the DOM. So I will just refer to an observable for that, which we don't have yet, but we will do that. So let's call it word observable, and we use the async pipe. If you don't know what the async pipe is, it basically is an Angular built-in gizmo that allows you to sort of, or pipe that allows you to automatically subscribe and unsubscribe from a property on your class. And that sort of makes it fast and easy to work with. There are other ways to do it, but this is sort of the more convenient way. So I'll save that and go to the component and get that observable to be. So when I work with observables, I really like this notion of sort of building it out step by step, because it seems to be that there's a lot of like boilerplate for sort of getting into it. And I like to start at the most sort of fundamental small level of what is an observable, what is the quickest way to sort of make an observable, subscribe to an observable. So the quickest way to do that is just to take some value over here. So we actually already lost that little thing. So let me just copy this and sort of go back in time. There we are, paste it here and take that one. So that's sort of our main sentence throughout. So we'll take that, put that in here. And yeah, so now we know that we obviously have the same result, but it's now sort of populated from our stream. And when you think of a stream, you think about data over time, and this is also data over time. The except difference is that it's immediate and it's only one sort of value, which is the string right here. But that's not what we want. We want to create sort of this animated thing that sort of rolls onto the screen as we go about it. So we can make a method. Let's call it spell word or something, and let's just say that it will return an observable, and we'll give it the generic type to say, okay, so what kind of observable? An observable that emits a string value, right? Okay. So we can obviously again go about it quite iteratively by just satisfying the method this way. And now we have done that, and we can refer to the method right here. It's no problem at all using the this keyword. So again, sort of same result. To prove the point, we are actually right there. So now what we want to do is we want to think about it a little bit differently, and actually sort of display every letter one after another to form the sentence. So what we can say is that we want to sort of get the word as a string. So instead of pushing it in, we will give it method call over there, and then we can take that word later on. So in this case, we don't want to use the off, the quickest way to create an observable, but we want to use another one called timer, which when in its current form, it will start to complain because we are not giving back a string, but we are returning a number, and that's not right. So, but before we are there, we first have to give it some default value. So the way that timer works is that it sort of takes two arguments. One is a starting argument where you say, okay, wait this long, and then start emitting a value every so many seconds. So yeah, let's do like 500 milliseconds, half a second. And then we can pipe those values starting at 0 all the way up to infinity, and sort of map those to the word that we are getting in, right? So we'll take whatever, let me just make the mapping a little bit more viewable. So we'll take whatever comes in, whatever sort of number comes in, and I guess you could also call it index. Yeah, let's call it index, and we can take that word and take its substring, and we know we always have to start at 0 and then towards the index of what we get, right? So, and if you're very sharp, I'm sort of allowing small little errors to sort of sip through, because I want to obviously explain the notion of sort of build testing, which we will get later to. Currently we're just building, but yeah, I want to sort of show you that although everything might seem in order, there are like these small little performance issues, and of course in the case of this that might be very small, but in order to get a really good grasp on streams and how to work with them, I think it's rather important that you sort of go in and really nitpick every part of it as to the best of your abilities. Yeah, so yeah, you can see it sort of being spelled. So first we wait that second, and then we're sort of getting that timer functionality to come in. So right now it's quite slow, so let's speed it up a little bit. There we are, right? So what I also like to do is to really use the tap and the logging capabilities, because I think that's a very powerful way to sort of see what's going on. So you can kind of see what's happening here. And immediately you can see a problem that, of course, during testing we would have found this, or in this case during logging, again, you don't sort of see it happening as you're here, because the re-rendering of the DOM or the repainting as it's happening here is so fast that we don't actually sort of see that happening all the time, right? So in order to stop that from happening, we can unsubscribe from the stream as soon as we have sort of satisfied the entire word, right? As soon as we know, like, okay, this word that we gave it has been spelled. So we can do that by using the take operator, which can be given a value, let's say 5, and then it will stop after 5 emissions. But we can then, of course, also give it the worth dot length, and then we are good to go, and we have sort of spelled it that way. Okay, great. Now, I guess we could also give it a custom speed, so that we can say, okay, we want to have the function call or the method call decide on its speed. That way it becomes just slightly more dynamic. Okay, that's great. So yeah, let's move on to testing, make sure everything works. Yeah, everything works. And we'll go to the spec file. So the first test that we wanted to do is we wanted to spell, right? Like that's kind of the main kind of functionality that we need to test. And this is sort of where the importance of understanding testing in a non-synchronous synchronous way comes in. So it sounds like a mouthful, like non-synchronous synchronous way. The basic idea is that we are flattening time, right? Time as a component of actual time is not something we want to deal with in a test. We don't want to wait for an observable stream to complete, as we find it pleasant in the context of the DOM and animation, or maybe we have reasons to wait, or maybe we want to delay certain actions, user actions, or sort of returns from APIs. We don't want that to happen in our tests if we can avoid it. We want to actually sort of keep the idea of time, but we don't want to have the actuality of time passing. So the way I like to think about this file in the context of a test versus this file in the context of build is that if you think of the two of us going to visit some town together, and we say, okay, let's meet here. Okay, we are actually there, and we're sort of having lunch. After that, we walk to the cinema. We're going into the cinema, see the film. After that, we go and have dinner. Then we have sort of done exactly what we are doing here, is we have experienced time as it passes, as opposed to here in the test, where we would be more reflective. Let's say the next day we are sort of looking at our picture book, and we're saying, oh, remember being there at 2 o'clock. Hey, we were there at 5 o'clock. And sort of you can already see that all of a sudden we went from 2 to 5 o'clock without that time obviously actively having passed. And that is kind of what we want to do in our test. So we have to think of this notion of time passing. So there are several ways to do that, and I will show you two ways that I think are quite successful, one more than the other. As the complexity builds out, we will see that the second one has just a little bit more handle on everything, where we feel more comfortable to use it. So what we can use is the fakeAsync callback, which let me see, this goes wrong. There we are, fakeAsync. Better right this time. There we are. Yeah, so what we can do now is we can get the observable from the component and assign it to let's say test OBS, and we can actually subscribe as we would do. So this sort of action that we're taking manually here is obviously automatically being done in the template through the async pipe. We are doing it by hand over here. And we can give it a callback, and let's say we want the spelled word to sort of, let's say, I don't know, word so far, I guess it is, word over time, and say that spelled word is equal to word so far. So this naming is kind of a little bit gimmicky, and I hope that through using this you see that there are some inconveniences we have to deal with, sort of having the expect and the assignment of the expect to sort of be disconnected through side effecting, and it feels uneasy. If you feel that, that's good. That's what you're supposed to feel, and that's why we will look at a better method. That being said, we can do an expect of words to equal whatever we put in. So let's just make sure that we are, actually this is wrong. We should obviously use the method call instead of referring to the field on the class, which we did now. So yeah, in the method call, just like before, we can give it a word, so test, and we can give it a speed. So let's do 1 second. Why not? And we can say that we think that this will equal test. But yeah, so this is now currently an approach where we haven't argued for time, right? We haven't said like, okay, this is an eventual truth, right? It's a truth at a certain moment in time, but it's absolutely not the truth right now, because the truth right now is probably that this is the empty string. Let's see. Expected 0 arguments, but got 2. Well, that's absolutely wrong. So let's make sure our jest is up to standards with us. Let's see. Okay, I'll just do a little restart on jest. Yeah, so obviously now it tells us that we are still not dealing with time, so we'll do that. And yeah, so we can sort of assume that in a normal test, this would be right to say that that would be the case, but in this case, we haven't accounted for time. So let's do that. And we can use tick for that by saying, okay, this is the time it is right now, right? This is just like how we are reflecting on our day out in the city. We say, hey, at 3 o'clock we were here. So let's do that. Yeah, so at what time are we at this case? Well, let's go back to saying test, because that's obviously a better thing to do, is to say that, okay, so we are at test at a certain moment in time, which is that we know that test will spell over a period of time, because test has 1, 2, 3, 4 letters in it. So we know that every letter takes a second because we just told that. So that would mean 4,000. The finicky thing is that, and I'm just going to show you that our, yeah, okay, let me just turn off the logging in this component, because that's just not helping us. Yeah, so our current logging that comes with jest and the expect are not as verbose as they can be, as we can see later, because currently it only gives us the difference between what it received and what it expected, but it doesn't give us any more information. We do see test and not test, so we can sort of go ahead and think like, okay, I guess we are 1 second too early, but we kind of really have to actively think about what goes on. And obviously for the watchful eye, we can see that spell words has a timer with a delay of 1 second, so everything that we give has to take that delay into consideration. So yeah, we can now just hard code that there and see that it should work fine, but it doesn't. Let's see, 386 then. Let's just restart jest. So you would almost think that in our current approach there's a bug, so we can look at that and see if this streams is actually being spelled. No, so you can see that our current take is not actually sufficient, in that it's yeah, one too little, I guess, or we should sort of account for the zeroed value that comes in at the first place that is not being taken into account at the substring. So for that to work, we need to +1 that one. Yeah, and you can see the test already passing, and we do have our right output right there, right? So we had a little bug in there that obviously I didn't see, because stream and streams both seems fine. So indeed, it's a testament to sort of try or sort of test building your solution as you go ahead. Obviously, we could have sort of done this all in build, but maybe it would be harder to spot because we are not actually doing a assertion towards our conceptions, but rather we're just reading out whatever comes to the DOM, which it can be sort of mistaken in that sense. Okay, so great. So we have our first test working, but let's now think about sort of maybe we want to work with something more complicated, right? Like what we have over here is obviously we have a sentence, and maybe the product owner will say, well, I want it to animate in a little bit smoother. I don't like the fact that it takes these little breaks, almost like little hiccups, every time there is a space, which just for the sake of showing becomes more apparent as we decrease the speed. So let me just close this down, go to the component, and make that somehow a little bit slower. Yeah, so you can sort of see it really hang at every sort of space, and maybe that's not something we want. So we can most certainly build that, right? So how we can think about that conceptually is that we want to offset the substring the moment there is a space happening, right? So yeah, the way that we can do that is by defining an offset. And there are definitely people who believe that sort of dealing with side effects inside of sort of a functional reactive pipe is bad practice. I concur to a certain degree. I do think that when you think about an offset within an already pure function, I don't believe that that is a huge problem, because sort of for me personally, mentally, it's much easier to sort of set aside the idea of an offset as sort of a special box outside the mainstream. But really that is up to debate, and it's definitely more healthy to sort of be aware of the benefits and cons and sort of make up your own mind about that. Yeah, so what we can do is we can have a tab which sort of deals with side effects, as we could see here in the console.log version, where we say, okay, take whatever you got and sort of log it to the console, and don't return us any value other than the value you had before in the map. That's exactly what tab does also in the case of an offset. So it can kind of help to increment this number as we experience or as we come across a space, right? So so we do get a word so far. So I don't know, let's do WS, and let's say that the word at the, actually it's kind of an index here, it's not really a word, it's a number. So at the index of that, if that is equal to the empty string, then we can say something like offset ++ else just do nothing. Okay, so yeah. Yeah, so now we know that we are offsetting every time we run across something like that. And then we can say that we want that one to be plus the offset, right? Because we want to go make sure that we are smooth in that sense, right? I think that worked. It's hard to see it at this speed. Let's log it. Make it a bit faster. Yeah. So that seems to do the job of sort of. And again, if I would go about this build, I would probably turn it on and off and see if I really did it well, see if the plussing happened well. But that's also where sort of the build testing notion comes in, that we go back to the test to see if we can account for this difference in situation, right? Because obviously with the current test in test, we only have a single word, no spaces. So it's definitely time for a second test where we say that should spell sentences smoothly. So this is sort of should spell words, and this is should spell sentences smoothly, right? So obviously, if we want to test sentences, we should give it a sentence. So let's give it a short sentence that obviously is no sentence, but for the sake of our ticks and everything, I think it will be good to do it that way. What we of course could do is, okay, give it a sentence, why not? Okay, short sentence, let's say hello world, right? And let's just make the increment speed then extremely small, so we don't have to deal with that so much. So this is 1 2 3, or sorry, 1 2 3 4 5 6 7 8 9 10. So that would be 10. So we can say that it's 1 0 10, like that, something like that. Yeah, let's see. Right, so we're expecting world, we received hello world. So let's turn off the log here again. Yeah, so we see that our thing has passed, and let's turn this one off. Still passing. That's not good. Let's see. So we can take a look at the log here. We can see here that we have a double of the importance and a double of off. So effectively it wasn't skipped. Yeah, obviously, because now we have it turned off. And now, yeah, we still do have that. So yeah, here you can see that if you look at it, we do have that empty space. So it seems that this is not working. If we take the offset. Okay, we do have an offset. And it starts at 0 for the first 3 letters, and then for 11 letters after that it has 1 offset. So I guess this one seems not to be working fine. Let's put a second log where we just console log the actual thing. Let's turn this one off. Okay, definitely smoother, right? So we had it before. Yeah, so that seems to be a problem. I guess we need to do it like that. It's really not liking this +1. Okay. Yeah, so this now it's definitely smoother. You can see it. And we have 4 logs at the end extra because that's probably the build-up of all the offsets. Yeah, so we have 4 offsets, so I guess we need to minus the offsets here. Right. And yeah, perfect. Oh, still 4 too many. And the offset here remains 0. Okay, let's see if we can take it at the end. Doesn't matter. Okay, right. I know what's wrong. We have to approach this a little bit differently. We have to calculate the offset in the take itself because this value is determined once, and after that it sort of doesn't update again. So what we can do is we can say that we want to take the worth length, split it, and then join it together. Not of course the word itself, and then take the length. Right, and perfect. And we do need that +1 back. Maybe. No, that's not gonna fly. Make sure this one is over here. -1, no, +1, sorry. Just map whatever number to +1 because we want to start from 1. Yep. And then we can take this away and then we can do the -1. Oh, apparently not. There we are. Okay, perfect. So now you can see that we solved another problem, which actually, let's just put that in for now. Yeah, let's put it in for now because this was actually something I wanted to keep as dessert for the more advanced tests where we're just going to pretend like we didn't see that small bug. So yeah, so yeah, we got it to work. Our test is still happy. Make sure it's actually happy. Sometimes it doesn't get that something changed. And that can make sense. Because we have 1, 2, 3. Let's just ease it down to A and B. And then we know that we have 2. Oh wait, 1002. And of course, A, B. Yeah, so now you can argue that I'm still happy. 1001. Right, at 1001 we have spelled A, 1000. We spelled nothing at 1000. At 1000 we spelled A, and at 1002 we spelled A and B. And if we would go back to the function and get rid of the offsetting logic, yeah, then we only spelled A. So there you can see the effect. But as you can already see sort of about the debugging, this observable over time in this manner where we sort of log and we have to sort of do ticks where we can only account for one moment in time, there must be a better way to sort of go about that. And there is. So we can use this notion of marble testing, and marble testing is very much related to marble diagram, which if you use the documentation of RxJS is a very common way to display a sort of a schematic of how values over time can change, right? So let's just sort of dive in and build a test that way. So for that, we can remove some of the boilerplate, so we don't need the fake async for that. We obviously don't need the ticks. We do need the observable. We can put it directly in an expect, why not? And we can take this away and start a test scheduler, which is sort of a built-in way to deal with marble diagrams. So we can say equal to get address, and then we can wrap that. And this is kind of common practice. I'm not going to go in and explain all the different things, besides the fact that I also am not really aware of everything that's happening, but that's not important to understand the concepts of what we are about to do. So we are going to expect not some equality, but we're going to expect an observable there, like that. And in order to sort of say, okay, we know that this returns an observable, we know that the method here returns an observable. As you can see, when you hover, it returns an observable string. And we need to say that we want to make our expectation based on what observable it is in a sort of over time fashion, right? So it's not the end result of the observable as we've seen before, where we say, okay, this is eventually going to spell A and B, and therefore we say at this moment in time, we're going to say it's A and B. No, in this approach, we are going to argue that we want to show whatever value it was over time, right? Not eventually, but whenever, right? So, yeah, so I guess we kind of have the same use case, but we will just call it marble testing. Okay, so the way it works is that we have this notion of an observable that we can sort of paint out much like we would do a diagram, right? So we can take an observable stream and feed it with a, I believe this should be cold. I'm not going to dive too much into the difference between hot and cold. That's definitely something to figure out, but maybe for the sake of this small introduction, it's not something you want to get into. But let's just give it some values for now, and let's kind of look at the debugging, because that's really where, in my eyes, a lot of the power lies, and especially this sort of received versus expected thing that we're getting right here, right? So what we're seeing is we get an array back with objects, and these objects have keys of frame, notification, which in itself has an object with a kind in it, and value, right? So, and it sort of goes on. And if we look at the first frame, so starting at 1000, and the second one being at 1001, and that's sort of the best way to go about it, is to look at the frames and see how they differ from each other. And that's kind of how you figure out what does it mean, why is it called frame, what are the notifications, what are values in this case. So we know that the first frame of 1000 has no value, which is surprising, and we know that the second frame has the value of A and the space that we wanted, right? And then there's a frame with the value of A and B, and then there's a last frame which has the kind of C, right? So the N kind means there's a next value coming out, the N of next. The C value means it's completed, and hence there are no values being emitted there. What we can also see, which is surprising, is that the first frame has no value, and that is a problem, which we actually already kind of addressed before by saying that we are actually getting an empty value in the first place. We can make that visible by doing the console logging in the DOM. I showed it before, but you can see here that the first value is not actually emitting something. And again, in the context of DOM and your eyes, that's something you would never see. It's only through sort of introspection and sort of getting really into standards with these testings and loggings and understanding the operators that becomes clear. So we kind of need to account for that. So yeah, we can obviously do that. Ways to do it. Return whatever value comes in, do the +1, and then we would need to change that as well, because now our sort of take is slightly different. Yeah. So, and you can see that our tests are still running and they're all passing, so that's good. And now we can sort of look back at that last test, which we haven't wrote an expectation for it. I will get to that, but we're sort of first looking at the receiving end to see if everything is in order there. I think that's sort of the best way to go about it, because it's just such a powerful way to read observable values over time, right? So now we can see that we start at frame 1000. And we do see that we have a value of A. So let's sort of circle back to what it actually means to be at frame 1000, because that's really where this understanding of time comes in, right? So we're really sort of expressing time in a very rudimentary way, where we say, okay, we're not talking about milliseconds, but at the same time we are referring to 1000s, which definitely refers to 1000 over here. Like we can show that by, if we say 10, we can see that we are actually at frame 10, but let's keep it at 1000. So what does it mean? It means that frame is sort of trying to intersect the notion of human time as seconds, but it's also trying to talk about time in a flattened version. So it took whatever we gave it here, and we could obviously make this an argument and then sort of flatten it so it starts nicely at 0. But for the sake of argument, we can definitely work with 1000 also in our expect. So let's sort of start with that. Let's make sure that our expect sort of starts at 1000 and admits something similar to what we have here, a value of A, right? Because that in the end is the idea. So how we would do that is we have all these frames, and we are actually already sort of outputting frames. In this case, we're outputting like 4 frames or something. And you can see that we are doing that there. We're not outputting a value. So let's start with outputting a value, and let's just do that here for now. And we can say that we output a value of null for the sake of argument, right? So now we can see that our expect has this A, and we can also see that our sort of array over time does have a bit more information. We can see that we are at frame 4. So again, flattened time, the notion of time has disappeared, and we can see 1, 2, 3, 4 frames, and then we admit a value, in this case of null. Okay, so let's first align these values. Of course, aligning sort of a test to make the test fit to your receiving end is a dangerous practice in many ways, because you should obviously test and be very self-critical if what you're testing is actually making sense and you're not just trying to fill the values you're getting. But in this case, I think it's safe to assume that this is exactly what we wanted, right? We wanted to have the A admitted and the space. So we can sort of go that way and just say A space, right? So so that brings that to a good close. The problem is that we are not at frame 4 at all. And that has to do with our starting condition, where we say, okay, we have given it an argument of 1, meaning that we want to make the timer admit every 1 millisecond, which is virtually nothing, but for the sake of testing, it's fine. You know, we could put it at 100, but I will definitely show you why 1 is the better option in this case. Let's put it at actually 1000, why not? And you would see that these frames are now incrementing by 1000 each time, right? But yeah, like I said, for our testing purposes, it's better to put it at a low frame rate if you want, because it just makes for easier expectation writings. Because how do we account for this first 1000 frames, right? We could definitely go ahead and go on with this until we reach 1000. I wouldn't recommend it. You know, we're now at 40, so you can imagine that being a hell of a job. But what we could do is, there is more syntax at our disposal, where we just say 1000 milliseconds like that, right? And then we would see that we would end up at 1000 frame, and then we are doing a next value, and we are saying that that value is A, and we're all good in that department, right? So now we do kind of see in a short way that we are our first frame expectation is right. But of course, we know that we have multiple frames because we are putting in a second letter in this case of our sentence. And for that to kind of work out, we need to give it a second argument. And let's be very clear that these can be anything. They can also be Y or H, but I'll keep it at B. As long as you match it over here, you can give it the value you expect, right? So what we expect at this point in time, if you will, is A and B. Okay. And then as a last result, we know that we have our unsubscribe logic at frame 1001. So what you can see here is that we have frame 1000, frame 1001, and we are not at frame 1002. So it's not unsubscribing the next frame, it's actually unsubscribing in the same frame that it's emitting a value. And that's definitely a possibility, right? So we do have given it the take operator, and we know that our take is quite sharp at the end of the sentence, so we unsubscribe right there. And that's something we need to learn how to tell that in our marble testing diagram. So the way we do an unsubscribe is by giving it the pipe symbol. However, once we subscribe like that, we are not unsubscribing in the, let's say, same frame, right? Oh wait, sorry, I was in the wrong place. I have to do that here, there, sorry. Yeah, so now we see that we are in frame 1001 and we have frame 1002, and that's where we are giving it the unsubscribe C of completed, but we don't have that in our received values because we are not unsubscribing the next frame, we're unsubscribing in the same moment of time. Of course, it being in a synchronous manner, we are definitely not awaiting our take any longer than we are supposed to. So the way we express that is by telling it to sort of compute all in that one frame by doing it like that. Right, so that makes our test work and our marble test complete in this case. So that sort of concludes this iterative approach between building, testing, and sort of improving along the way, and especially in the importance of streams, which are finicky. They have small little changes depending on how they're being used. You know, this is obviously a very sort of visual thing. I see that we are having only one of these guys, but when it comes to other types of wait, did we not save? No, we did not save. When it comes to other kinds of usage of streams, this importance can become much more apparent, because in this case we solved a couple of problems, like for example emitting values when it's not necessary yet, or admitting double values at the end. But when you think of streams as, for example, making requests, let's say we are filling out some kind of form and on every keystroke we are making a round trip to the server, we would rather want to have exact control at any time that this stream is still emitting exactly what it should but not too many times, right? And sort of going the testing route is just gonna improve your mental model a whole lot in order to really get that sort of muscle memory with those concepts. So yeah, it's been an absolute blast sort of talking about this. I hope you appreciate this form where I'm actually going in and sort of debugging as I go along, not video editing it and sort of showing it the pretty matter, which you see a lot online. I think it's really good to sort of go in and go about it that way. And if you see this approach and you have better ideas, you know, if you have sort of fancy ways to avoid the offset being used outside of the observable, please do come back to me. I really appreciate that. So thank you for now.